Hi mathematicians, I am going to do an example from 3.6. And so 3.6 might seem a little intimidating because it seems like they're all word problems, and maybe it seems like they're all word problems because they kind of all are. But we can do this, okay? So I'm just going to go ahead and pick number 22, and we'll see what kind of adventure this brings us on. And so 22, we're talking about a dropped stone on Mars, and this is something that might be applicable to one of you someday. We obviously are more and more interested in sending autonomous vehicles to Mars in the hopes that someday we can colonize there. So if that's something you're interested in, maybe you're interested in this word problem. So it says that a stone is dropped off the edge of a 54-foot cliff. We're in Mars here. I don't know, I'll make a little alien. If I was in Mars, maybe this is what I would. But maybe I have extra legs, right? I mean, because I am an alien. And maybe I have 2 heads. I don't know. But anyway, so here, oh, you can't see my alien. So there's my alien. We're on Mars. So Mars, right? What do we know about Mars? I guess it's kind of red. I'm gonna go ahead. I'm probably doing a little overkill here, but if I can find my crayons, I'm totally gonna color this. There we go. Bear with me for a second. And I really do. I know I'm being like a little overzealous about this problem right now, but I really do encourage you, because Mars is the red planet, right? To give yourself a little context, right? Don't be like, oh my god, I have this word problem, what's going on, right? Well, have a little fun with it, right? I'm going to have a little green alien here. Right? And he's going to drop a stone. But at least we'll have something fun to look at if we get sad at any point, right? So that's always helpful. Okay, there we go. All right, so what's it say? I haven't even gotten through it. All right, we dropped off the edge 54 feet. So we know that this is 54 feet. Okay, acceleration due to gravity here on Mars is 12 feet per second squared. Okay, we'll write that down. And the height in feet of the stone above the ground t seconds after it is dropped. So they're giving us this equation, -6t squared plus 54. Okay, and this is the height in feet t seconds after dropped, right? Okay, and so we haven't even gotten to the questionnaire. Here it is. Find the velocity of the stone and its speed when it hits the ground. Find velocity of stone and its speed when it hits the ground. This is a great problem. Okay. So let me raise this up so we can see the whole big picture, right? We're going to see my alien. Okay. And so he's dropping, I know he's a little far away, but he dropped this alien stone here. Okay. And we are saying that this function here, this relationship, represents where this stone is at any given time, right? And let's just take a second. And let's just look at this guy for a second, okay? Let's do a t table, and I'll do the s or t. I really was going to put height, but I'm going to above it write height. Okay, the s or t is the height, right? And so when I plug in t0 here, right, you can see this obviously becomes 0. And where are we? At 54 feet. Does that make sense? It does make sense, right? What happens at time equal to 1 second? Okay, so why is this negative? right? What's happening? We want to subtract from this feet, right? This is the max we are ever going to be at this 54. And so after each second, we're getting farther and farther and farther and farther down, right? So at 1, we get negative 6 times 1 plus 54. That's going to be 48. So we're at 48 feet, right? And so you know that you speed up, right? Like if you jump out of an airplane, you speed up until you hit terminal velocity, right? So we're not going to hit terminal velocity here. So we're assuming no, this is a frictionless rock, FYI, but we'll worry about that later. So what if we put 2 in here? If I put 2 in here, I'm going to get negative 6 times 4. What's 6 times 4? Well, 6 times 2 is 12. 12 plus 12 is 24. So I have negative 24 plus 54. That is going to be 30 feet. When time equals 3, we're going to have negative 6 times 9. Ooh, what is negative 6 times 9, party people? We finally made it, right? At time equal to 3, we were at 0 feet. Now, why did I do this? Well, I just kind of did it to get a sense for what's happening here and to trust this equation, right? This equation makes sense, right? At 0, we're at the top. After 3 feet, we've made it to the bottom. Find the velocity of the stone and its speed when it hits the ground. Okay, so this is the way that the homework video is going to tell you to do. Okay, what does this mean for when this hits the ground? If it hits the ground, it means that its height is 0. So we're looking for when it hits the ground. We're looking for the time when S of t equals 0. So we could just make this equal to 0 minus 6t squared plus 54 and go ahead and solve this, okay? To go ahead and solve this, I'm going to put 54 on the other side. I'm going to divide everything by negative 6. I get 9 equals t squared. T equals 3. Right here. Okay? In theory, both are fine, all right, because we got this exact position. But again, I really just did this part just because I'm just trying to feel comfortable with this equation, that I can trust it, that it makes sense to me, that I understand what's going on. This is negative because we're falling. We're going towards the ground. This is the highest we're ever going to be, right? We start at time equals 0. Right, that's when we drop the stone. Again, this is a frictionless situation here. And did we answer the question? Find the velocity of stone and its speed when it hits the ground. Well, we didn't do those things. We just found when it hits the ground. It hits the ground at time equal to 3. So let's go ahead and take our position equation, and we know that S prime is going to give me my velocity equation. And so we get negative 12t plus 54. So V of 3 equals negative 36 plus 54. What does that give us? Negative 36 plus 54. We're going to end up with, I'm trying to do math in my head, 18 feet per second. There we go. Okay, I'm missing a negative sign here though, somewhere. It's making me uncomfortable because I do want this velocity to be, oh, well, of course, Beth, what did you do? You took the derivative wrong. Do you see that? Were you screaming at me? Yes, this, oh, erase that guy. Erase that guy. That's all wrong. I'm glad you saw me make that mistake. Why am I glad you saw me make the mistakes? Because we all make mistakes, and it's okay. That's why. Okay, so negative 36, that's much better. Feet per second. Right? It's important that afterwards, like I was like, why is this positive? That's a problem. I need my velocity to be negative because we're going towards the Earth. We're not the Earth in this situation, Mars, right? But we're going down, and we've defined down as negative. Okay? Now the second question is, what is the speed? Well, the speed is going to be the absolute value of the velocity. So speed is always going to be positive. Speed is. That's a little better. Sorry about my videography tonight. So the speed is 36 feet per second. Okay? All right, and again, this was number 22 from section 3.6.